Hi, so my name's Nick Zeeble. I'm a principal geologist with AMC Consultants here in the UK, at the main head office. Personally, I've been involved in the industry since graduating from Camborne School of Mines in 2006. So I've been in the industry now for over 12 years. And been doing mineral resource estimation work and geological work ever since.
So I'm Justin Glanville. I'm the Geology Manager and Principal Consultant at AMC here in the UK. Been in resource geology or in geology since 1997. Started working in the Wits and moved my way through the world and ended up here in the UK about 6 years ago. AMC as a company has been around since 1983 in various incarnations, where it was started in Australia. We've grown the business dramatically over the last number of years. We've just recently opened our Moscow office and really established ourselves as a group of advisors of choice to the industry, essentially. We are looking at, within the resource space, at a way of helping companies quantify their risk and manage their risk from multiple aspects. So it's not just the risk associated with drilling a nuggety gold deposit. It's the risk associated by the hydrology of the situation, the geotech, the mining, the processing, and incorporating that into the central resource estimate at the end of the day. So what we want to try and do with an AMC is continue to evolve that offering. And we see data mine as a fundamental part of that, because it gives us that ability to estimate anything we want into a block model, do just about anything we want to a drill hole file or a wireframe file or a Rosette file for that matter. It just gives us that sort of multi-tool that you need to solve your problems. AMC as a company has standardized on data mine from the beginning. And the primary reason is its flexibility and the ability to dive into the data in an unprecedented manner. Very few other packages out there give you the level of fundamental control over your source data that Datamine does, which is a very valuable tool within the consulting space, because we deal with such disparate data sets of such differing quality. We're also able to we're able to develop our own tools. The macro and the scripting language that Datamine has enabled within it is, again, gives us just an unprecedented level of control over our analysis or our interrogation or our manipulation or whatever you want to term it of the primary data that we receive. We can do stuff in Datamine at a fundamental level that is very, very difficult in some of the more conventional packages out there, at least from our experience. Just about anybody can do a resource estimate. Just about anybody can import a drill hole file and desurvey it and generate a rudimentary model. That's not the problem. It's solving those unique and special problems, those sort of intractable challenges that companies face and put to one side because it's too hard to solve. And being able to pick that problem up and generate a unique, stable, user-friendly solution at the end of the day, either through a script or just through working through the problem with my team and the client, is just so satisfying. And being able to pull the data apart and construct these elegant, fun, however you want to view them, tools to do that, that's the fun part, is coming up with that clever fix. That means that the client has saved money, we've had fun, we've learned something, and we can move forward with an expanded knowledge base.
I think it really is the raw data functionality of it. Some of the what people would call the basic functions, but are very powerful. So the extra commands, the the ability to tailor macros and scripts for the software. I think that's where I find the best benefits of the software packages, that raw adjustability that we can get into the nuts and bolts of the data and really pull more out of it than possibly with other software.
What we find in AMC is we have a lot of projects that are coming up at us where there's this older data set that isn't quite as good as the newer data. And people are needing to incorporate this information. There's not the same amount of cache that's available in the old days to just re-drill or recapture or anything. And we had a particular example where a client had this large legacy data set of geotechnical information, and they needed this information incorporated into a three-dimensional model to enhance their support planning, support requirements within the mine plan, as it were.
What we acquired was a database for RQD values, but it had been established initially qualitatively. So initially, the geologists at the time just logged, weakly fractured, moderately fractured, strongly fractured RQD values, and then assigned a numerical value to it. So the database only had 3 sets of values, 20, 40, or 90.
They found that the linear estimates that they were generating were not wholly rational. They just didn't make sense. You'd end up with an average of 70 where most of your data was sitting at 20 and occasional at 90. And that just meant that the results of that conventional linear estimate were not very helpful.
So say in this case we had 3 different options. So for that we adopted the multiple indicator kriging approach. So with the MIK approach, what we did was we were working with the probabilities rather than the average grade output. So by running it and getting the probabilities, we could then statistically look for any given block, what is the probability of it being either a 20, a 40, or a 90 value. And that was really the key strength, using those probability values.
So we sat down, and within the RM framework, we realized that using the INDEST, or indicator estimation approach, would be a fantastic way of getting these qualitative bins into the block model. We then used a random function model or Monte Carlo simulation essentially, and sampled the resulting indicator distribution to generate a probable range of RQD values on a block by block basis within this 3D model. From that probable range of values, we are able to quite happily draw an expected value, or a mean value. We could look at the median distribution, because a lot of these were skewed distributions, so the median is often a rational choice. We could look at the maximum and minimum ranges, which is again a very useful parameter in the geotech space. And we were then able to calibrate the results of the estimate against some recently captured face mapping and drilling data. So we were able to tweak the estimate within the RM space to get a stable response that actually beautifully replicated the expected values of RQD within the block model. The way we calibrated the model and was basically on a block by block basis. So we would have available information in point form. We were able to query the block model and the point data against each other and make sure that the values were within range, with a reasonable range of each other. We were able to look at the broader statistics of the data set within that informed space and compare the overall distributions, and if they made sense, then we kept that estimate. If they didn't make sense, then the estimate was adjusted to get closer parity. It's very similar to the adjustment that you would apply to a grade estimate, where you would tweak, where you have a known grade tonnage curve, and you then tweak your linear estimate to achieve a parity in your grade tonnage curve. So the final stage of the project essentially meant that we were able to generate this usable RQD model that had been ground truthed against available information in a small restricted area. It meant that we didn't have to go back. The client didn't have to go and spend additional funds to try and recapture data or capture new data at great expense. And they were able to progress their model with a good understanding of the probable ground conditions going forward. It essentially was a massive cost saving for them just through the simple application of a couple basic steps within the RM system. Seems to have proven to, well, it has proven to be quite a stable model. The engineers were certainly happy with it, so yeah, if the engineers are happy, everyone's happy.
We can use it for other data sets. It's applicable where you don't have a continuous data set, where it's more discrete parcels of data. I mean, when you're dealing with grade data, it's going to be a lot of linear estimates, but when you get onto coarse gold and stuff, that's when, of course, your non-linear estimates really sort of kick in. In terms of other data with more discrete values, I guess it would be a lot of geotechnical information, maybe geometallurgy. I could really see an application there for geometallurgy. Also, you could possibly look at hydrological inputs and really sort of put more data into the block model than just a simple grade estimate, which a lot of people use currently. And really see if you can put in the process data, geotechnical, the hydrological, you can build up quite a powerful tool for mine planners.
This approach is, in many respects, a generic solution for discrete nonlinear data sets. We can apply it to any sort of categorical variable, provided it's nominally sequential categorical variables. Actually, it doesn't even have to be that.
The obvious one, of course, is grade control. I've worked on an iron ore mine in northern Norway, and we used our resource models for the grade control. So we had a large-scale resource block model and then small-scale grade control. And we set it up so that we could run a series of macros very quickly with the grade control data. So we really sort of built up a robust short-term model. Gave us, because we were running grade control in advance, it gave us the next 3 benches worth of production. And then that allowed us to then also reconcile against our production data coming out of the pit and the feed grade to really sort of see where the block model, the resource model is honouring our production and where we're seeing bigger deviations. And if needed, what we would then do is go back and refine the resource estimate to ensure it kept alignment with our new interpretations.